call Derek.
Right, that's what I mean. Well, yeah. Like, how do you know the difference between a cinder pound, all the cinder pounds?
So yes, you have your midterm on Thursday, right here, 11 o'clock sharp. Bring a good pencil with an eraser because you'll be working on the Scantron. It'll be, is it okay if we don't do an essay?
Yeah.
But it will be an awful lot like the clickers. You will see clicker questions that you've already viewed. True, false. And then there'll be two kinds of multiple choice. Regular multiple choice and then multiple choice where I show you an image and you can identify it from the list of choices. Okay? Like I'll show you perhaps Mauna Loa. You go down to Cinder Cone, Shield Volcano, Hoi Hoi. All right. And then there'll be fill in the blank. Okay? So, and I'm going to try to run class and get done a little early today so we can have a review for those that are interested. I will actually pull up some questions that I've used in the past and that you haven't seen as clickers, and we can talk about those. Does that sound cool? Yeah. So anyway, I'm here every day. I'll be around a good part all tomorrow, all afternoon. So if you have any questions, come see me. Question now.
Are there going to be lab questions on these?
There will not be lab questions. Yeah. The lab quizzes test you in lab. There's some overlap, of course, but at times labs go independently. Good question. No lab stuff. Any other questions? Yeah? You can email me, but come see me. Come see me. You know, our office hours are like the loneliest times of our lives. We're there, and nobody comes by. I think maybe 3 of you come by. And you didn't really want very much. We're nice people. We like our students a lot. We want to help you. It's okay. Yes. Yeah, it includes today. So we'll look at the syllabus through today. All right. You've all got emails from me about the video, including the echo. It's now running. Use your computers. You knew that, right? You have looked.
That's pretty good.
All right. So you know that we've got both the echo filming and the video filming over here there for you so you can review. All right, but I'm glad you're here. Next step, get brave, get off of ComAv, get out of the coffee shop, go find Dr. Ray, come find my office just downstairs on the first floor. Walk into the main department office, 141. I think my room is J. Or James, that's my first name, J. And if you do that, you get to see a picture of me when I was a junior in high school, right on my door. All right? Kind of look different. And it's okay to come in and not know stuff.
Yeah.
Right? It's okay to come in. I don't know this, I don't know that. Don't be embarrassed. If you knew it all, I wouldn't have a job. So come on in. All right? The class before this is a math class. Differential equations. Now I was talking to the professor. And I made a grand confession. Some of you were here. I said, well, I got to confess, I took Diffie Q twice. What does that mean? I flunked it. So we all have stuff going on. All right? Okay, clickers. Out we go. I'm sorry, I got in front. Here we go. Let's see. I reset the slides. Auto. Go over here. From our second volcanism lecture, the port town of St. Pierre on the Caribbean island of Martinique was destroyed by a nuée ardente. What do you think? I open the polls. Real exam questions. You're firing away. There's the countdown. 8, 7. Get them out. Get them out. Let me know you're here. Good. Good. Excellent. And you said, how did we do? 85% of you said true. Take a picture of it. And that is correct answer. Okay? Excellent. But if you're in that 15% mark, you got a little studying to do, but now you know, imprint, imprint. It's okay not to get it right. You're in a safe haven here. Ocean crust, melts during subduction. What's ocean crust mostly made out of? Okay, oh man. Melts during subduction, forming andesite magma, the dominant volcanic rock of island arcs. What do you think? The polls are open. Here goes our countdown. 10, 9, fire away, fire away. I want all of you to do wonderfully. Hurry up, 2 more seconds. 1. All right. Polls are closed. 74% said true. And that's true. Okay? So ocean crust, why isn't it basalt? Ocean crust is made out of basalt. If I melted basalt, why don't I just get basalt? Because you only melt part of it. Why? Because magma leaves. Like teenagers leaving home, can't wait to get out of there. I'm gone, I'm on a job, no, maybe you don't. I want to go to school. All I know is, I'm not staying here anymore. And you're out of the house. All right? And that's the way magma is. It starts, I'm melting. And melt expands, it expands, and it leaves. It is buoyant. So you only melt part of it, maybe 25%. So it's a different rock. You're only melting the lightest fraction. You melt basalt, you melt mantle, peridotite, you get basalt. You melt basalt, you get andesite. And then if you melt andesite, island arcs are made out of andesite, you melt the bottom of the island arc made out of andesite, you get the next rock. What is it? The most viscous. The most rhyolite. Right on! Rhyolite. Okay? Rhyolite. Melt andesite, you get rhyolite. So we're clicking away. Next one is andesite and rhyolitic eruptions. Rhyolitic eruptions tend to be explosive because of their gas content and their high viscosity. True, false? Which is it? The polls are now open. The countdown is on. 80, 90 of you, 102 of you, 113 of you. Come on, come on. Get over 130. Almost. 87% said true. Would I trick you? Look at this head. But you got it right. Absolutely. They are explosive, like a stick of dynamite. They get, the gas is trying to come out. They've got more gas. They can't get out because it's so viscous. Why are andesite and rhyolite more viscous? 2 reasons. Higher silica and lower temperature. Yeah. Okay. You know, I think there's going to be a whole lot of good grades here. And that's good. All right? Are you with me? Yeah. Volcanic activity of the Cascade Mountain Range of the Pacific Northwest results from continental collision. And now, the polls are now open. Fire away and count down. Cascade Mountain Range of the Pacific Northwest, Cascadia, results from continental collision. 1 second left. 132 said. 73% said true. Look at this face. It's false. What collision? What continental collision? Is there a continent sitting outside the state of Washington colliding with it? No, what's subducting there is ocean crust. So Dr. A got you. Not meaning to, all right? But some things are going to be false, and you've got to have it around, okay? All right? You're subducting. You're still subducting. Someday there will be continental collision, subduction. We know the Wilson cycle. You rift, you make oceans, but someday the oceans will close. You start subducting at their margins. And once you start subducting oceans at their margin, you start closing that ocean and you get continental collision. And then it re-rifts again, all right, and splits that mountain range created by continental collision to ended up on both sides. All right, so that's the Wilson cycle. Just an extra review in there all the time. Now, number 5, rhyolite is the least fluid, most viscous form of lava because high temperature, low silica, high temperature, high silica, low temperature, low silica, low temperature, high silica, or none of the above. And what did I just say? Okay, polls are open. Countdown is on. 6, hurry up. There you go. 106 of you. Some of you are still thinking. 2 more seconds. Fire anything. Okay, 71% said number 4, and that is correct. Low temperature, high silica. Okay, we're in printing. That's the correct answer. Basalts, just on the other side, basalt is the most fluid, least viscous, because it's the highest temperature, it has the lowest silica. So the converse is true. You will see one of those two questions, one or the other. Mount St. Helens blew its head off. Is an example of a shield volcano, a cinder cone volcano, a composite or stratovolcano, an extinct volcano, a basaltic volcano. Oh, hell, I can't remember. Yes, you can. Yes, you can. There's the countdown. Polls are open. 40 of you, 60 of you, 70, 80 of you. Come on. There you go. 3 more seconds. Fire away. Fire anything. 136 of you got them out this time. And you're all over the map. But that's okay. You're safe here. The correct answer is, that check is a bit off. Number 3. Mount St. Helens is huge. Cinder cones are small. Cinder cones are made out of basalt. That's not Mount St. Helens. Cinder cones are made out of pyroclastic cinder. All right? You can run up the sides of a cinder cone. Okay? And then, of course, the shield volcano. Nobody else, a lot of you chose that. That's Mauna Loa or Mauna Kea. Big, broad, all basalt lava. Okay? The big volcanoes above subduction zones are called composite or stratovolcanoes because they're made of layers. Composite, alternating layers of lava and pyroclastic debris. Lava and pyroclastic debris. Lava, pyroclastic debris going up and coming back down. Plinian style eruptions, pyroclastic. A new ergodons, pyroclastic. Okay, making those pyroclastic layers. So they are made of 2 different kinds of layers. There we go. All right. We quit. Get rid of the old PowerPoint. Don't save it. But save the session data. There we go. It goes there. Uh-oh. There you are. All right, our day's topic are landslides, mass wasting. The landslides is the general term. The scientific term is mass wasting. And mass wasting, I think you probably thought that's something you did on Thursday and Friday and Saturday nights. Mass wasting. All kinds of landslides. And it's a form of erosion. Plate tectonics builds up the topography of our continent, causes mountains to rise, and the first thing they do is they start tumbling down. All right, rivers is an agent of erosion. Glaciers are an agent of erosion. All right, wind is a small, not very effective agent of erosion. But the number one who's out there first, you'll learn later that water is the greatest agent of erosion. And certainly glaciers are powerful. Wind is the weakest. But the first one often there is just gravity. All right, I used to play football back down in South Texas, and coaches would always tell us this. You go in, you get tackled, you get killed. He'd get you back up, and he says, "What's the matter with you? Get back out there." And he'd say, "But I say, they're so big." And what would he tell you then? That's right. He says, the bigger they are, the harder they fall. I think that was BS, because I just got killed out there. But the mountains go up and they come down. What's wrong with this picture? Here we are on a coastline. I am saving you multiple times today. Could you ever buy a home in a place like that? I don't care if it's on the coast of Maine or the coast of California. You've got to turn off my email. It's going to go on all lecture. All right. Could you? What is that? Right. Memorize that. That is a scarp. S-C-A-R-P. Scarp. It's so raw, so new. The land is falling away. The landslide is happening. When landslides fall, you're going to see different forms of landslides today. But one thing they all do is they pull down. They leave a scarp. All the vegetation is gone, raw rock. And landslides are not like lightning. They say lightning won't strike in the same place twice. You can forget that. But landslides surely could happen over and over in the same place. In fact, one of the ways to predict landslides is to look for evidence of prior landslides. Okay? Look at that. Who built those homes there? All right? What county authority gave the permit to build those homes there? And who amongst you would buy one of those homes right there? With children, Earl, don't do it, Earl. Earl and Emily, they met right here, Geology 108, 105, fell deeply in love, graduated together from BU, made tons of good dollars, gave some back to BU, of course, and bought their third home right there because they forgot my word. No, they wouldn't do that. Emily will save Earl. Emily will. So there are two main factors here. As the land goes up, it gets too steep. And I'm going to show you what the angle of repose is. All right? And then water. Water is a grand lubricant. All right? Now I know you can take sand, as I will in a moment, and wet it just a little bit and make a sand castle that goes way up. But when water saturates, it just fluidizes everything. A lot of landslides happen during major rainstorms or melting of snow. Okay? As I will show you in just a moment. So that's a landslide. And here it is, angle of repose. Here is a conveyor belt taking sand out, dropping its sand. It's a sand and gravel operation. The angle of repose is that angle of stability. It depends on grain size and whether or not water's there. So it's not a constant. But it is approximately a constant depending on the grain size. You can take cobbles and boulders and build something up pretty steep. Go to finer sand, the angle of repose, the limit of stability is lower. Add water to it during the rainstorms and the equation's all off. It just flows out. And let me show you. From Home Depot, wonderful, beautiful sand. All right? And I'm going to start pouring the sand. It's raining, it's pouring, la 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 la, raining. And look at that angle. Can you see it? It angles. Raining, it's pouring, I like it bigger. Raining, it's pouring. The size count. Raining, it's pouring. Look at that angle. We're just getting this over and over and over. Whoa, 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 whoa. And I got a mountain. Okay, I've got a mountain. Look at that. Angle of repose. All right, Caleb? Caleb? Is that you? Yeah. All right, so Caleb comes in, he's going to build a home on top of the mountain with Tori. And he says, we'll put a home right there, but the first thing I got to do is get the Caterpillar tractor out and cut a road into it. All right? Watch what happens when we cut a road cut into the side of the mountain. On this side and on that side. Watch. I pull, boom, it failed. Boom, it failed. Reset. On this side, boom, it failed. Boom, it failed. Okay, come up here after class and make a landslide. All right? Nothing like it. So it's going to reset. So when you go in and you cut, landslides are natural. What's unnatural is that when we ignore nature and go put ourselves at the base of a mountain that's going to fall on you, or the top of the mountain that's going to fall with you. Okay? Even here, as you'll see in good old Massachusetts. All right, so off we go. Off we go. Well, we're going to go through different kinds of landslides or mass wasting, rock falls where things fall down. Look at that house here outside Culver City, California. Rock falls are the fastest. They come tumbling down. Rock avalanches are fast as well and have the capacity to become airborne like a frisbee. All right? Like a snow avalanche. Snow avalanche becomes airborne too. Cascading down, so much of it. Then we'll look at slower forms we call rock slides. Even slower, slump, slow, and then finally really slow creep. So would you, could you, first rock falls, the rock falls. All right? Would you, could you scrape away all of this and put a house right there? Would you do that? No, because Dr. A's yelling at you, right? This nice, beautiful cliff. Move your house away from it and enjoy it. All right? It has cracks, we call joints. All right? And when it rains, water gets in that crack, and then when it freezes at night, what does water do when it freezes? It expands. This is called frost wedging. So every night it expands. Next day, it's opened the crack up more. The next day, that water melts, goes back further down. It keeps doing it, keeps doing it. And then finally, it's going to tumble down. Look at all of that. It builds up at the bottom. It's called talus. Builds up at the bottom, lovely, at the angle of repose. All right? See that? Talus or scree, it's called, rock falls. Look at that beautiful, all created by rock falls. One or two or a whole lot of them at one time. Here's some of my boys when they were young playing around on a geology field trip. Except he's doing it wrong. What's he doing wrong there? He's pulling it toward him. Look out! John, so he got out of the way. Boulder rolling is great fun in geology circles. I've had lots of students come up with me and they just can't wait to start their own landslide. And then you learn the power of gravity. All right? Gravity. I was once being interviewed for a Discovery Channel show on landslides, and going over the ways you could tell whether or not landslides will happen, or you could guess that landslides will happen. And I used the word gravity kills. Ends up being the title of the show. So if you ever see Gravity Kills, if you're up late with insomnia and you can't sleep, turn on Discovery, you might find that show. Look at this. Whoa! British Columbia, Kootenai, one or two at a time. The road has been closed. Gravity kills. Keep coming down, ain't no repose, right out in the road. I've got a video coming for you in just a moment. Here we go, two of you. Hey. One more. Oh, there's a good one. Wow. Oh yeah. Boom. Don't you love that? Let's do it again. Oh yeah. Same one. Whoa. Gravity. Rock falls. God, I love that. Don't you just feel better already? Not like a little demolition to get things going in the morning. I'm with you. And so stuff can come down pits at a time or a whole lot of it. There's a whole lot of it. Oh my God! I don't think they're kayaking today. They just happen to have the camera on. I am all over YouTube. Whoa! Look at King. Whoa! Salton River, Washington. So mountains go up and they're going to start coming down. 4 agents of erosion. And the first one, not the most powerful, but the focus of the day, is just the role of gravity. Okay? Often activated with earthquakes, often activated with water lubricating. There we go. So those are rock falls. Also pretty fast are rock avalanches. They're the same thing as snow avalanches. How many of you have seen rock or snow avalanches? How many of you have seen snow avalanches? Yeah, they're scary. They're what? How many of you have seen a rock avalanche? Where were you? New Zealand. Pretty scary?
Yeah, and the road that we were traveling on, there was an avalanche and you had to go over the top of the mountain.
Wow. Anybody else? Where were you? Dominican Republic. All right, very active. Where were you? New Zealand. Where were you? Dominican Republic. Plate boundaries. Where were you? Switzerland. All right, collision. Little collision. All right, so this stuff, it goes up and it's going to come down. And like snow avalanches, rock avalanches are really spectacular. They go so fast, over 100 miles per hour, they have ability, like a giant airplane, of lifting and going airborne. All right? Because they're so thick, air can't get through them. I mean, what makes a frisbee float? Air can't get through it. It traps air. So these things will hit a slope and literally can go airborne. Here's a couple of examples. These things are really flying. I'll show you a picture of Mount Shasta and Black Hawk. But rock avalanches, they come down and they carve the mountainside. The bottom, there will be talus or some other similar kind of deposit. But when you go up and you look here, look at that. These are called avalanche chutes, where the rock avalanches have been happening. It's carving its own path. There's talus, all right? Here's an avalanche chute. Here is outside Interstate 5 in Northern California, near Mount Shasta. There's Mount Shasta. These volcanic mountains are rising because of volcanism, and then they come down, all right? And parts of this is a huge frisbee-like, over 200 feet high, that came down, went out, traveled all the way out to Interstate 5 before Interstate 5 was there. It's prehistoric. I don't know exactly when it happened, but we now recognize that all of this irregular, hummocky ground around volcanoes and the bottoms of mountains are due to avalanches. All right? They make really weird looking ground. And now we know there. Look at that one. That one looks like a pancake. That's the Black Hawk avalanche. All right? It's estimated we've gotten speeds up to 270 miles per hour. All right? Southern California. Wow. 80 seconds of travel, prehistoric. It's all estimated. Look at it. It's just weird. And how did it get there? Where was its path? Now, back up this way somewhere, because it was flying. So those are rock avalanches like snow avalanches. Slides are slower. They don't become airborne, but they do come down a slide surface like you on a playground coming down a slide. They come down a slide surface. It will either be a fracture surface, we call it joint, or a bedding plane. All right, so here is a river valley, and this is called dip slope conditions because the bedding or fractures are parallel